Moving back into section 9.2, these multi-stage experiments. We had done some last time with some tree diagrams. They were your favorites. Maybe not, but you're going to get more comfortable with them, and we're going to do some more of them today. And we're going to take a look at example 5. All right, here's an example for example 5. Joe says that if a family has 2 children, then their only possibilities are 2 boys, 2 girls, or 1 of each. Because there are only 3 possibilities, the possibility of having 2 boys is 1/3. Is Joe correct? So we're going to draw a tree diagram to explain whether he is or is not correct. So somebody gets pregnant with 1 baby, which means that I can draw a tree diagram with 2 branches, right? Because the issue in this particular question is whether or not the children are boys or girls. So mom has baby, and baby is either boy or girl. And the likelihood of each of those is 1/2. So that goes on my tree, my branches on my trees. That is what happens when we have 1 baby. But they said we have 2, right? They have 2 children. So off of each of these, no matter whether we had a boy or a girl to begin with, we have another child. And each of these branches looks just like the branch I just drew, right? B, G, E, G. And what numbers go along these branches? 1/2, right? There's a 1/2 chance when I have a child that it is a boy, and a 1/2 chance that it's a girl. So Joe is talking about the likelihood of having 2 boys. That's this branch right here. What is the likelihood of having 2 boys? What is it? This 1/4. Where are we getting? How are we getting 1/4? Yes. So this is what we did last time. We talked about multiplying along a tree branch. This would be the multiplication to give me 1/4. So there is a 1/4 chance that he has, or that a family would have 2 boys. Why was it 1/4 when he thought it would be 1/3? What's going on?
You can have the children in different order, like boy, girl.
Right. So the ordering is different. Namely, there are actually 4 possibilities. We could have 2 boys, we could have a boy and then a girl, or we could have a girl and then a boy, or then we could have the last option is having 2 girls. So it is different when you have a boy and then a girl than it is if you have a girl and a boy. You still have 1 of each, right? But it is a different ordering. I know that when I had my daughter, my husband was really hoping for a boy first because he wanted an older brother for his children. That was important to him. Not crucially important, right? Didn't happen, it's all okay. But it was something that he sort of talked about, this idea of having an older brother. He is an older brother. This is why he thought this was important. I don't have an older brother. I turned out fine. So this was of value. It's something that would be different than having a girl and a boy in an ordering. So if we actually looked at this, then what's the likelihood of having a girl and a boy if you have 2 children? It's actually 1/2, isn't it? That is the more likely combination. But we all know families that have 2 boys or have 2 girls as well. Those things happen, right? Okay. Let's take a look at another one. Is anybody familiar with Huntington's disease? Anyone ever heard of it before? Great. I hope you never have to hear of it ever again after this discussion. Huntington's disease is a disease that runs in my family. My grandmother had Huntington's disease. My father also has it. It's genetic. So you either are born with it and you will show symptoms later on in your life, or you're not born with it and you will never get it. Make sense? It's kind of like being a boy or a girl. You're either born a boy and you're always a boy, or you're born a girl and you're always a girl. Okay, you either do or you don't have this feature as a part of your life. In 2001, my parents decided to tell us what Grandma had. We knew Grandma was sick. We just didn't know what the deal was. And they decided that they were going to share this news with us. Huntington's affects your central nervous system, so it starts shutting down your fine motor abilities and eventually your gross motor abilities. So at this point, my father has a really difficult time swallowing. That's a fine motor skill, right? Being able to swallow. that's obviously problematic if you're going to actually be able to eat. He has a great amount of difficulty walking. So my son will tell you that my father walks like this. And he does it to balance because he's incredibly unbalanced on his feet. I have some specific memories from when I was real young, my grandmother was still with us. And you guys know like the soft serve ice creams, like at a Golden Corral or something like that. And she couldn't, the time it took for her brain to tell her hand to stop, getting the ice cream out of there was too long, and so she had ice cream everywhere. It delays your reaction times. So things like being able to drive a vehicle are slowly taken away from you. And so this is what Huntington's does. It's an absolutely horrible disease. It's horrible. And if you have the disease, as my father does, and you have children, each one of your children have a 50-50 chance of having Huntington's disease. Okay? So in 2001, my parents decided to tell us that this was prevalent. I know you guys were, how old were you in 2001? How old? 6? 8? I'm going to have to change this example next time I use it. You guys are making me feel old. 2001, my parents decided to share this information, and I have 2 siblings. So let me talk first about the question. The first question is, what's the probability at least one of the 3 of us has it? Well, my husband and I were living in Kansas at the time, and they shared this information on Thanksgiving of all times. Yes, no joke. Hey, by the way, you may have this disease. And I was married, my sister was married, my brother was seriously dating the girl that he is now married to, the woman he's married to now. They've been married for quite a while now, but so we were all with our, intendeds at that point. And they decided to share this information. And they decided to share the information because, not because there's a cure, because there is no cure, but they decided to share this information because of in vitro fertilization. You could actually have a child and avoid them having that gene. And so we were told about this information, told about this possibility of having children with in vitro and all of this. And my husband and I are not in our home because we don't live there in Oklahoma at the time, and trying to figure out what we're going to do. And this question is what ran through my mind, is what's the probability that at least one of us has it? And so the first thing we're going to do is we're going to draw a diagram to show how my mind was thinking about this particular problem. So the first person in the family born was me. So this branch is me. And for me, there is either the possibility that I have Huntington's or I don't. And what's the likelihood that I have it? 1/2. And I'll do it in decimals this time since I did fractions the last time. It's the same thing. My sister is the second child in our family. So these branches represent my sister. My sister either has it or she doesn't. And what are the numbers along those branches? Yeah, it's the same 0.5s, right?
Why does the chances of it go down?
The chances doesn't go down. The chances are still 0.5 every single time.
But for your sister
Mhm.
would be the second column, so it would be 0.5 times 0.5.
But see, the second column, like let's say for instance, Kinsey, that we wanted to find out the probability that my sister and I both have it. This right here tells us the probability that both of us have it, not that she has it.
Okay,
She still has a 50-50 shot.
okay.
Okay. I have a third sibling, my brother. My brother is the third set of branches on this tree. Thank you. So the third set of branches, of course, match the same as the other ones because the probabilities are the same. We either have it or you don't. And they're all 0.5s. This is the tree diagram of what was going on in my mind. I wasn't thinking of it in terms of a tree, but I was thinking about the math behind what the tree is going to show us. Okay. So the question that we're asked first is, what is the probability that at least one of us one of the three of us has this disease. So how could I find that based on this picture? There's two ways to do it. Okay, so that's a really good idea. So this is one of the ways Hannah just mentioned. I could go along each branch, and I could select all of the branches where at least one of us has it. Are you guys with me? So we could do this one at a time. What do you see, the first branch? Yep, all of us would have it on the first branch. How about that second branch? That'd work. The third branch? Yeah. The fourth branch? Yes. How about the fifth branch? We're finally down on the bottom half. Yes. The sixth branch? Yeah. The seventh branch? Yes. And the eighth branch? No. So there's only one branch that doesn't classify in this description, right? So all of the other branches. Okay, so one way I could do it is I could multiply along each of those 7 branches and then add those values together. That's the hard way to do it. What would the easier way to do it be? You guys are sort of saying it all under your breath, so somebody be bold and tell me what it is. Okay, so that's true. That's true because all of these are equal probabilities. I don't want to do it that way because if these numbers had not all been 0.5, it wouldn't work. Okay? So, because the reason I say this is because you're going to have an example where you're going to do an example with, I think it's going to be a disease. I can't remember if it's deafness or something like that. But they're not going to all be 0.5s. There's going to be 0.7s and 0.3s in different places. Yes, Becca?
Would it be 1 minus the probability? So since the fourth branch or whatever, it doesn't have you do the 3 and multiply.
Yeah, this branch is the only one that doesn't work, right? So we could actually figure out what this value is with all 3 of these multiplied, and then it doesn't matter whether they are the same or not. So if I take this branch and I multiply along that branch,
Then 1 minus that.
yeah. So I can do, and I'm going to write it in some words so you guys have some language to associate with this. One way of doing this is I could actually find 1 minus the probability that none of us have it. Right? That's the only way that not one of us, at least one of us has it, is if none of us do. All right? So this is 1 minus, and I've got the 3.5s multiplied. So what does that work out to being? You're right, it's 1 minus 0.125. Okay, and then what is that when we subtract? So there is an 87.5% chance, 87.5% chance that at least one of my brother and my sister and I will have this disease. That's really high. And that's the number that was ringing in my mind as I went to bed that night, and that's why I was a little bit freaking out. That's a huge percentage. This is going to continue to affect my family more likely than not, right? It is. And so my husband and I decided, well, what are we going to do about this information? What are we going to do? So the only reason my family decided to tell us is because there was this option where we could have a child and avoid having the disease. Basically, the way the option works is that, if you're familiar at all with in vitro, is that they create the embryos, and then they would actually let the embryos grow to 8 cells, I think it is. They would test each of the embryos, however many were created, and any of the embryos that had the gene for Huntington's disease would not be used. And my husband and I thought, sounds a little bit too much like playing God for us. We weren't comfortable with that. I don't necessarily have anything wrong with in vitro, but the fact that you're choosing which embryo to implant was a problem for us. And we also thought that our family was being a little short-sighted. This isn't the only way I can be a parent, right? And so this was actually the first point in our lives, my husband and I, where we looked at each other and said, maybe we should adopt. And so we made the decision that night that I would be tested, and if I had Huntington's disease, we would still be parents and we would adopt. That is the 2001 is when we decided we were going to adopt if this happened. So in 2003, I was tested for Huntington's, and I do not have Huntington's disease. I will never have the symptoms. I will never go down that road. But God had already placed it on our hearts that He wanted us to adopt. So the reason I have my son is because Huntington's is in my family. But the reason I have my daughter is because I don't have it. When I didn't have Huntington's disease, we decided we would go ahead and see if we could have a child ourselves biologically. And we do. We have our daughter. But God made it really clear to us through that 2 years that we were processing through and deciding what to do, that adoption would be part of our story. And because I have my son, at some point I will have my daughter in Ethiopia as well. And so the fact that that plays into her story is just gives me tingles. My brother and my sister have not made the decision to be tested. So we're going to do the last half of this question with what happens because this situation now happened. So if you take a look back at this original diagram, the original diagram had the option, remember I was the first person listed here, and I either have Huntington's or I don't. So we know that we're down here in this diagram now, right? So the part of the diagram that's sort of still, if you will, in effect is this portion of the diagram. And notice, even if I wanted to include the don't here, it wouldn't have a 0.5 anymore, right? It's not a 50-50 shot. I know this is a 1, and that's a 0. So the part of the diagram that still applies was that part in that green box. It's the part of the diagram that had the 2 branches going like this. And they all had 0.5s along them. So if we use this diagram now to answer the same kind of question that we had just a minute ago, what we're looking at is what is the likelihood that at least one of my siblings has it? So we already answered this question, but from a bigger picture. How could I use this diagram to help answer the question this time? What did we do last time? So we subtracted everything. Well, we subtracted this last one because it's the only one that didn't have at least one of them having it, right? So this would be 1 minus the probability that neither have it. This is 1 minus 0.5 times the 0.5. So what is this? That is 0.25. And then 1 minus 0.25, 0.75. So I look at my brother and my sister, and I still know that there is a 75% chance that at least one of them has the disease. Yes, Shana?
So, just with the disease, do you not know you have it until, like, you don't get the symptoms until...
Right. So there's a couple things with the disease. There's juvenile onset. So there are some people who will show symptoms very young, as early as like teenage years. And this is the funny thing, I know we haven't gotten to statistics yet, but we will get to statistics in chapter 10. The age of that your parents has it when the symptoms start showing is roughly the age that they would start showing for you. So for my father, I think that was early 50s, maybe late 40s, something like that. That's the average age that it would show up in either of my siblings if they have it. But then there's a plus or minus the standard deviation, like how far off you might be, and it's a plus or minus 18 years. So it can vary extreme. I mean, like my brother or my sister could have it, and they could never show symptoms until they're in their 70s. I mean, that could happen. Yes?
Do your siblings have kids?
Yeah. My sister has 3 children, and my brother has 2 children, and it's really scary. Sort of. It's also similar to Parkinson's disease. You see tics. One of the things that I remember really distinctly from my grandmother was her inability to control certain hand movements and repetitive nature of certain things she says. My dad's that way now too. My dad says, I don't understand a lot. And it just, pray for my mom. She's really struggling. Really, really struggling with my dad right now. He's still mobile, but I mean, she's done the Heimlich on him twice. You know, he can't communicate with her to any kind of a reasonable degree any longer. I mean, she's very much become his caretaker. And, you know, you sign on for that when you get married, right? I mean, you know that's the possibility, but that's not where you want things to go. And so it's been a really difficult last couple of years. My dad has had no driver's license and not been working now for about 3 or 4 years. I mean, it's really difficult. You know, he was the primary breadwinner growing up in manual labor. So when you take away his ability to get up on a roof because he's a roofer, you just took away his identity. I mean, really, very much took away his identity. And more he's digressed to the point where it doesn't really resonate any longer. He's less resistive to it. But it's still really, really difficult on my mom. And at this point, the other thing, too, is, I don't know if you guys have ever heard this before. This is a bit of trivia for you. You've heard people tell you, you know, you should twitch, like you should fidget. Fidgeting, you know, burns calories, right? Yeah, fidget. We could all benefit from fidgeting, I think. Well, my father fidgets so much that he can't consume enough calories to maintain his weight. And so he's always been, you know, a pretty muscular guy. He's ridden bikes, he's run. I mean, he's been very physically fit. He's a roofer, right? He's skin and bones. I mean, he just has nothing on him. I don't know how he can continue to go on where he's going for too much longer before his body just won't, it won't take care of itself. And that's a problem too.